So you go to workshop, create another fluid flow, right click on geometry, open that type, okay. Now you want to sketch a rectangle. Then it's important to be in millimeters. And then you want to make it have specific dimensions. Make the height 5 millimeters and the length 7. Book concept. Surface from sketch. Box the
40% chance of rain. 4 to 6 is not working. Can I move this up? Can you pull this in?
Yes, you can throw that out. Oh, it doesn't matter. They don't probably watch the videos anyways. Let's see. Okay. Yeah, I'm still recording. So geometry is done. Now you want to start the mesh. My computer is very slow. Okay. Just loading. And okay, so it's gonna be kind of annoying. Maybe it does that, but. Okay. Fine. Bottom border. Then you also have to do the outlet. Oh, there it is. Okay. Yeah, wasn't opening properly. So start that again. Bottom border. I'm gonna zoom in a little bit. You get the inlet, and then you also get the outlet. Okay, insert sizing. I'm going to do that to outside ones. Apply geometry. Instead of element size, we're going to do number of divisions. Let's do 50 for this first one. Capture curvature, no. Want it to be hard behavior, and then generate. Okay, that one's done, so back to mesh, insert sizing. Now you can do the top and the bottom border. Apply. By elements, no, number of divisions, you want to do say 500. Not curvature, hard. Generate, this might take a while, so I might do for that. It's done. Okay, now that that second one is done, you want to insert face meshing. Select the whole object. All those settings are good, so generate. Okay, that one's done, so that should be all for meshing. Select mesh. You can now zoom in. Looks black, but once you get close to it, you can see that it has meshing. You can go back to Workbench. Now you want to update it. Okay, so it's giving an error. Or just open it up for Workbench. Okay. And you click here, see the error. Overlapped geometry. Okay, some reason decided to make a copy of each type. Okay. Go back to workshop. And that should be solved. Yep. Okay, so now open setup. Double precision. And start. Just gotta give it a second to load, so a slow-ish computer. Okay, now you want to go to models. Go to viscous, and you want to select laminar. Okay. Next you want to go to materials, fluids, air. This one will do density of 1 with viscosity of 1/e⁻⁵. Change and close. And then we want to go to boundary conditions for the inlet velocity. See, it's at velocity inlet, so that's good. Now for meters per second, let's do 2.04 meters per second. Apply, close. Now the outlet. Prevent reverse first flow, apply, close. For the walls, bottom border. Make sure it's stationary, non-slip. Same with the top wall. Slip. Okay. I'm going to recheck the reference values. Usually these like changing. Just put that back to 1. And this to 1 e to the minus 5. Okay, now you get to initialization. Initialize. You should have 10 values down here. Okay, it's done. So I put to run calculation. Number of iterations is 200. Calculate. Okay, it's done. So you can go back to workshop. All you gotta do is the results. I'm gonna let it load for a second. Change the view. Then you wanna add 3 lines. So the first would be developing region. Okay. So you want that where you can see where it's starting to develop. So closer to the inlet. Just 0.025. For some reason the value is like changing. It's kind of frustrating. Set that to 100, which might have to change later, depends on how the graph is looking. Okay, add another line. This would be the midline. Just want to add that at the center, so 0.375. 0.375. And again, this will change for some reason. 0.05. And then set that to 100 samples. Apply. And then you want to do end. And this would be at 0.75. 0.75. 2.5. And then again, 100 samples. Okay, now you want to insert contour. 110. On it based on symmetry 1 and velocity u. Apply. Might take a second. Okay, and then this always gets in the way, so now horizontal, center, it should go up here. Next you want to insert the chart. So I'll call it velocity contour for Poisson flow. Then you want to add the midline. x-axis should be velocity u, y-axis would be y. And then, as you can see from here, you have the developing region and the end line. As you can see, it is not very organized. I'm going to go back and change all these to f-thousand samples, and that will better curve it. And then, as you can see, the midline and the end line are almost exactly the same because it is developed for the whole region. So they will literally be the same as each other. Then you want to go back to chart, and then you can export the data. Save. Okay. You can exit out of there. And now we are going to do the covette flow. So again, you do fluid flow fluent. Open geometry with design modeler. Okay. Sketching a rectangle in the XY plane. Probably best to tune it 2 millimeters. Dimensions. I'll do the same dimensions as the last one. And then again, you want to do surface from sketch. Turn that box select it, and generate. So you should have the whole object now. So you can go back to workbench, and then you can insert mesh. And then you will be doing mesh the same as last time. You want to go to select, name section, top order. Generate. Don't forget to click generate, otherwise it won't make continue at all. I'm going to do that for the outlet also. Okay, now you can zoom out, center, put back in. Ah, of course, it's in the wrong thing. Okay. probably feel like there's gonna be double this one also, but I will worry about that later if it does come up. Sizing. We should make sure it's getting both sides. Yep, 2 edges. You can do the exact same thing as you did last time. 50. No. And hard. Generate. This one should not take very long. Insert sizing. And this one does take a while because it has a lot of divisions. Very hard. Generate. almost done. Going to finish that, same as last time. Insert surface mesh, or face meshing. Select the whole object, and then generate. Double precision. Okay. Okay, so this one will be a little bit different. Models, viscous lamina will be the same. And then materials, make sure it's still air. So density will be 1. And for viscosity, 0.001. Change grade, close. So at the inlet, you'll need to change the pipe. So inlet type, pressure inlet, prevent reverse flow. Then for the outlet, also want to prevent reverse flow. Then for the walls, the bottom border will be stationary non-slip. Stationary non-slip, okay. But for the top border, it'll be moving at moving wall, I'll say 8 meters per second. You just pick whatever, as long as it fits the Reynolds number. Do you want to go to reference values? 3.001. set it as 1. Initialize. Let's guess a 10. So this one, then run calculation. Just take 200 iterations, calculate. Okay, once it's done, go back to workshop, and then click on results. Then you want to add the developing region. This one should be relatively close to the inlet. So maybe 0.125, 0.05. Let's do 1,000 iterations. Sample section. Then you want to do another line. You want to do the midline. 0.375. 0.375. 0.5. Let's do 1,000. And then, just so you can see the difference temporarily, I'll keep this one at 100 samples. Now you want to insert the contour. You want to do it at symmetry 1 and velocity u with 110 contours. Apply. And then the legend, of course, as the other one was, will be in the middle of the viewing area, so horizontal, and then center. That will move it either way. Now you want to insert a chart. We will call this flow velocity. I'm going to insert the developing region. The midline. And the endline. And the x-axis will be velocity u, y-axis will be y. Apply. Up to the developing region for some reason. But you can see how the midline and endline are basically exactly the same. Okay, now I'll try to do a smaller value for the developing region so that it's visible. And that's too small. Basically, the explanation behind this is when you got the plate moving, it's developing at all areas. So you won't really have a developing region. So actually, probably get rid of the developing region. And then you get the end line and the midline, which are equivalent. Right? So you get there, you can do chart 1, you can export the data, choose a secure folder to put it in. Save. Now we're going to do the experimental flow. So again, fluid flow fluent. Open Don't just open it right away. Otherwise you're gonna have to wait for the other one to load, and then you're gonna have to exit out of it to do the specific things. Okay, so you want to open it in New Designer Modular Geometry. Then again, this will be basically the same as the first two parts. You want to have it in millimeters, you want to do dimensions. Okay. Go back to this. Now you want to create the mesh. Okay. So top one will be top border. bottom border. Inlet, then I'm going to create the mesh, insert sizing. Apply geometry. You want to do it by number of divisions. In this case, we'll do 50 divisions. No, you do not want the curvature. And you want it to be hard to hit. And then generate. Okay. So insert sizing. Do for the top and the bottom regions. Apply. It should have those yellow lines. Now you want to do it by number of divisions. 2,500 divisions. No, you do not want curvature. And you want it hard. So let's generate that. Install recording. Nope. Connor? Dad?
Dad went to Lowe's.
Last time I saw there was something on the burner.
They were where?
Last time I saw there was something on the burner.
Oh.
Okay, once you finish the second mesh, you can go to insert face meshing. Apply geometry, and then you can generate. Okay. Then you should be able to go and update this in Workbench. Okay, yep, it worked. Okay, you can open Setup, Double Precision, Start. This one will take a minute to load. Okay, this is going to be a little bit different. Let's go to Models, Viscous Laminar. Okay, you want to go to Materials, make sure it's Air. Density 1, viscosity 0.001. Okay, we go to boundary conditions, the inlet. There will be a velocity inlet. So we'll be doing 0.8 meters per second. Apply close. And for the outlet, again, you do not want it to have reverse flow. Now for the walls, the top border will be moving. So it would be a moving wall with 0.5 meters per second. You don't want it to slip. Close that. And the bottom border, make sure it's non-slip, stationary. Stationary, non-slip. Okay. And then you want to check the reference values. Density F1, viscosity of 0.001. That should be good. Initialize it. And then you can run the calculation. Okay, once that is done, you can go back to workshop and click on the result graph. So now insert the contour. Symmetry run. Velocity U, 110. Okay, and then you want to insert 3 lines. You want the region, and you want that to be towards the inlet. So 0.025. And do 2,000 samples for that one. And then you want to do the midline. And then do the end line. 0.75. And then keep this one as 100 so that you can see the difference. And then you want to insert a chart. Its name will be okay. Data series, you want to put in developing medium. The midline and the end line. Okay. You're gonna apply that. Looks like you want the developing region to be a little bit farther. Let's try that. Nope, then it's too close. That's still too close. So let's try 3. Okay, that's a good developing region. And then you can see the difference between the midline and the end line, though they are very close. So, put it back to 100 so you can see it. Go to chart 1. Export. Okay, once you finish that, that will be all for the experiment.